back in 2000, and you said three things which we have followed quite clearly. Said that V6 is not overhyped, and at that time we were scared that we are hyping V6. So that gave us a bit of reassurance that we are on the right path. The second thing, you said that industry won't make it happen. And boy, that scared us quite a bit because we had to get everyone on board. Then you mentioned there is hope. You should go back to the US government. If somebody can help with the presentation. And yes, we went back to the US government first, and we did that with the other governments. And I think that was a very good approach to find the business case for the industry, to move forward. So if your presentation is there.
Yeah, I see it here.
So if we can launch it.
On the screen, but let's try that and see that.
So Bob will talk to us about something else, which is the alternative solution to DNS, which he has been working on for quite a while. And by the way, we have also Patrice here with us, and I would like to honor your presence with us because you have basically trademarked the word internet, and even the French didn't, make it, translate into something. So it's the only technology word that the French have used without changing it. It's called the internet. So thanks for trademarking the internet. Yes, Bob.
Okay, well, thank you very much, Latif, and everybody in the audience. I'm delighted to be here. Glad to see some old friends and meet some new ones. I wanted to start out by pointing out that while the devil is in the details, and many people have spent their lives on the devils in IPv6, the difference between IPv4 and IPv6, if you look at it from a sufficiently high level, is a parameter change, if you think about it. And how long have we spent going from V4 to V6, and will we ever be able to make that change again? Latif is telling me we have long since given up going to V8. We're now going to leapfrog to V10, maybe at some time in the future. I don't know if that's before or after 5G, but presumably we will find a need for it, because no matter what parameters we think is sufficient today, and remember, we thought 8 bits of network address was okay back in the early 70s, we're going to find it's short as we go into the future. So that's comment number one. Comment number two is I have tended to look at things a little differently now than I did when I first started working in this area. And one dimension that you're looking at here is what I would call the here and now. It's the communications dimension, where everything has to be interpreted very rapidly in order to move information from one place to another. But there's a whole other cut at this problem, which I've been working on, which I started out actually with Vint Cerf when he was employee number 2 at CNRI back in the 80s, which was how should we approach the task of using internet space to manage information more generally? So if we're talking about that, we're talking about all kinds of information and the need to manage it over space and time. So we're not talking about just now, but how do we still access information that was created now and be able to manifest that 50 years from now, 100 years from now, maybe even millennia from now? And how do you do it in a way that's secure, interoperable with other systems, which is a classic IPv4 problem, and to do it in a way that deals with this issue of persistence in an effective way. So what I'm going to talk about today is really a component of something we call the digital object architecture. This is an approach we came up with for managing information. It's very generic. I mean, it's so generic it would be the equivalent of, in the computing field, saying we have a CPU chip and a memory chip. This does not invent computing. It does not even give you a clue as to all the things that are going to happen to deal with it, like creating operating systems, interfaces, programming languages, and the like. And none of this is going to solve all those problems. It still leaves the issue of information management to the people who are managing it. But just like we could do virtually everything in the internet today, back in probably the 1960s in a given machine, but everybody had to be on that machine, and everything had to be of the kind that machine only could understand. What the internet did was exploded it worldwide. So now you can have different machines of different kinds, and the lingua franca with the protocols and procedures that made everything work together. Well, if you can imagine a database in today's parlance, and it's all in one place and all the data is there, different databases of different kinds don't work together. But suppose you could take the one database and essentially blow it up worldwide, explode it to the point where people could store information in different kinds from different times in different places, and it still all work together by virtue of the protocols and procedures. You would have essentially what the digital object architecture was trying to achieve. Well, it's here today, but it's at the protocol level, the component level, and it's all intended to be open source and available to everybody. So I would commend it to you. I'm going to focus my remarks today on one piece, one component, which is something we call the handle system, but what it is a general purpose identifier/resolution system that allows you to identify anything, and I guess I would take that notion of thing, which was really an extrapolation from devices where we started out originally, and say that that's a subset of something more generic called an entity. An entity being anything that's got a separate existence and can be uniquely identifiable. So entities may not be in digital form, so you can have digital versions of entities. We tend to think of them as digital objects, and you can manage them in a variety of ways. This is one piece, it's the identifier piece, but it's the linchpin of this whole information management world, just like IP addresses are the linchpin of making the internet work. So that's what I want to focus on, and I think it's relevant to IPv6 because, if nothing else, IPv6 addresses are going to be in large supply, large quantity, and people are going to need to manage them too for purposes other than perhaps just moving the bits around. And so I think that's where the linkage comes in. I've pointed this out before, but I think in many ways the message has got to come at the right time. And IPv6 is now starting to get the kind of traction where I think it may be extremely important now. And I know other folks, including my colleague Peter Kirstein and various others, have been looking at its use for the IoT as well. So there's no limit to what you can use it for. The question is, does it fit the bill? Do people understand it? I'll try to give you a little feeling for that. So this is more of it's not a very technical talk, but it's more technical than some of the other talks, so I hope you bear with me, and I'll try and finish. Well, originally it was scheduled for, so we can go a little bit longer. So let's see if the slides will work here. Does that go? Does that go? Okay, so I want to start out by talking a little bit about binding. One of the things that we did originally, because we didn't know any better, was in the world of communications, we bound identifiers to the technology. In the ARPANET, the identifiers were the wires on the net where the computers were. When we moved into the internet world with multiple nets, those wires sometimes went to other nets, and rather than having to tell every network where to direct the traffic, we invented this notion of IP addresses. Now you would say IPv4, but we had a really advanced notion that we might have some 200 and some odd networks in the world eventually, so we gave 8 bits to network identifiers. Turned out not to be enough very, very quickly when the Ethernets came along. But that's what internet addresses were. They identified the machine, so you didn't have to worry about instructing everything along the way how to do the routing. When the web came along, they concatenated 2 things: the IP address or the domain name of the machine with the name of the file on the machine to hopefully manifest the information. And the observation that we made is if you're managing information and you really want it to go beyond the here and now, what you really need to do is identify the information, not some attribute of the technology that was being used. What good does it do to tell somebody, even today, that here's the URL for a piece of information when the URL doesn't resolve anymore? Whereas if you could say, this is the piece of information I want, let the technology of the day figure out how to get it to you. So that's what it's all about. And in our parlance, these identifiers resolve to what we call state information about the thing that you're identifying, such as it could be a whole set of IP addresses, whether v4, v6, v10, or v whatever, I suppose, in the future. You could have authentication information, public keys where you're identifying an entity that might be an individual in digital form. Terms and conditions, fees, all the things that people struggle with today are built into the system along with its own intrinsic PKI infrastructure. So, and it's available for people to just use. You can download the software and all the other components of this architecture. The problem is that you really need to be at the level of a wizard today to really make use of it. So it really is only for technical people who have the imagination to want to figure out what to do with it. If you recall, in the early days of the internet, the way we got the internet out the door wasn't by advertising to people. You could get TCP/IP here, or you could get an LSI 11 interface there, or you could hook up your applications this way. It came when Sun Microsystems, which was another little project of mine at Stanford, decided to package everything together and propagate the protocols in the turnkey implementation. This will happen here too, and we are seeing it in various forms. So it'll get easier over time. I said that the handle system was a component of the architecture. I'm not going to go into the details here, but these are the things that are relevant. There is a notion of a data model. There is a notion of a protocol to deal with the data model using identifiers only. There is a notion of a repository, which is not about the storage technology, but it's an interface into information based on identifiers only. And in fact, we've shown it working with the clouds, and it can work with SDNs as well. The notion of registries, which let you essentially catalog metadata records so that you can find things and understand what they are. I guess everybody knows what metadata is these days, but this is a registry that allows you to collect them, and in fact it uses repository technology to store it. So these are the components of the system. A major component of the registry are what we call type registries, which allow you to define different types of things so that when you create an object, you can actually go into the object and look at all the type value pairs and understand what the types mean independent of the language that you're using. So it can be done and it's all encoded in Unicode, so it can be represented in various ways. So those are the components. I'm not going to say anything more about that today. It's a whole other topic. But I do want to mention a recommendation that came out of ITU. It's more like a framework recommendation, if you will. I'm sure everybody in the audience knows what the 7-layer model was that came out of ISO back in the 1970s. This is a framework recommendation, and it tells how to think about the problem of interoperability between heterogeneous information systems. By virtue of the track that it took, and I think there were various companies that were involved in the process, including Cisco was involved and a number of others, it was finally approved last year. It just describes a framework in which you can think about this thing. So there's actually now a global standard that the countries of the world have bought into, and you can download it from the ITU site if you want. There's no charge anymore. It formally talks about identity management information. That's only because it had to get slotted in a working group, but it's really about any kind of information at all if you just read it carefully. So I commend to you that recommendation X1255. Now, the handle system is very general purpose. It's been operational on the internet, in the internet since 1993. So this goes back 20 years. It's widely used, probably got as much raw information in it as the DNS system does. It's not necessarily used as much because if you're trying to go in and access a resource, which might be a publication, you're not going to do it many times a second. You might, how many movies might you try to access in the course of a day or whatever? So we're running several 100 million accesses of the root part of the system every month, whereas the DNS is probably running that much every second. So there's like 4 or 5 orders of magnitude different between the demand on the system, but the root database is probably similar. So what it allows you to do is map these identifiers into state information about the things you're identifying. And the users get to define what that state information is. And it's as powerful as what a pencil can write on a piece of paper. There are no real constraints on it. And when we started out with this, it was only V4 because that's all we had. Many of the groups that were interested in V6 had brought it to our attention, and we, within the last few years, addressed the V6 issue. So it now supports both V4 and V6. The issue was not with the system itself. You could always put a V6 address in it. The issues all had to do with dealing with the carriers and making sure that, like, if you had a V4 client and something else was on a V4 network, it could work, or vice versa, and that everything could kind of work interoperably, and I think we're there right now. In terms of handle structure, we're not inventing the identifiers. All we're doing is saying you can use any system you like, including existing ones. The only thing that's needed to make sure your identifiers are different from anybody else's is we put a prefix in front of it, which is a number. We decided not to fall into the trademark trap we did, and so we actually are giving out numbers. There are about 10,000 or more organizations around the world that are currently minting their own identifiers and running identifier services. All the records are kept locally to the party that creates it. So that's good for the banks, that's good for the publishers, it's good for anybody who cares about the integrity of their information. The only thing that's critical is to figure out which of these 10,000 around the globe you're supposed to go to, because you don't want to try them all. So there's a global registry that's maintained. We've been maintaining that for the last 20 years, and it's been working out perfectly fine. We found in a number of cases, I'll give you one example in the case of its use in China, which was done in conjunction with the publishers. They had a number of places in China that they needed to go to do these identifier resolutions, but they had to come across the Pacific and ask us where to go in China. And so they said, can't we please distribute that global registry, which we did. So there are mirrors around the globe. So now they could ask locally there. Also, the question was posed to us by the folks from Max Planck originally, who were starting to get involved in the big data initiatives in Europe. I was on the Future Internet Committee at the time. The question was, if they were to use this to identify the big data sets and the things they were working on in research data, what would happen if our organization, which did all the administration, ran into troubles? We ran out of money, or we got shut down, or something. And we said, well, look, we'll be happy to work with you and come up with a plan, which we did. We had a set of alternatives. Many other countries who were interested also raised the same question, and we sat down and tried to find a solution. And make a long story short, there were political issues. You probably just read about the issues about ICANN in the papers. So it was very similar like that, but in very different genre. So we're dealing about research data, we're dealing about information, in some cases governmental information from those countries. How would we deal with it going forward? And the conclusion that came after lots of discussion, I had discussion in my country, we had discussions around the globe, was that a foundation based in Geneva was probably the best solution by far. So I'll tell you a little bit about that as well. So right now we're allocating these numeric prefixes, but once somebody is allocated a numeric prefix, just like in DNS you can create subdomains, you can create prefixes derived from a prefix that you get. So if somebody got a prefix like 1,000, they could create 1,000.1, 1,000.a, 1,000.a.headquarters, or whatever they want, to almost any level going down. And every one of those prefixes grants a separate authority to mint identifiers starting with that prefix under a separate security regime available only to that administrator. Let's just see, this will give you a feeling for what the system looks like. It's got a lot of moving pieces, just like IPv6 is not as simple as just a 128-bit string. And this is not just as simple as a box that you give an identifier to and you get a handle record, but it's got the global registry, it's got many local systems. Local systems can be spread out in different sites. Sites could be a geographic area, it could be any other grouping, and every site can be made at n machines. And so, site 1 could have n machines, and site 2 could have m machines, so you could have different numbers at different places. And it uses spreading and hashing to get uniform distribution across it. So it's a very powerful representation, and I believe there are no limits to its scalability that we have any clue of right now. So let me just say a little bit about IPv6 and then briefly about the foundation, and then I'll wrap up. I believe this is now compatible with IPv6. In the past, if you were an IPv4 client, all you could do is deal with IPv4 services. Now all of the services are dual stack, and they will remain so in the future. So anyone who wants to participate in the global registry must provide that service on a dual stack basis. But we can't make any such requirement on the local handle services because people can do with them what they want. So we're now kind of fielding the ability to do mapping from one set to the other for people who don't handle both. And in fact, even though these identifiers can be resolved directly in the services, people who don't want to download the clients to do the handle resolution directly can use plain vanilla browsers and things like that and go through proxy services, which will do the same. So these handles are literally just identifiers, and people try to pigeonhole them. So we've had people say, well, are they the same as URLs? And what I say is they can be represented as a URL and therefore treated that way. They can be represented as a URN, treated that way. They can be represented as a URI. They can be represented as OpenIDs or any other form you want, or in native form, and they can be dealt with in any of those contexts. So they're not one or the other. They're essentially all of them all at once, if you wish. What we are bringing up is a caching handle service and recommending that people use them where that is appropriate to do the mapping. And if parties who had IPv6 only services are encouraged to essentially advertise the IPv4 address of their caching service, it would make it available to others. So a lot of things that could be done here. They're more in the level of processes. So this is what the centralized management of the global registry looks like. This is the part of the system that will tell you from any address that based on the prefix only, where you go to get the actual state information that corresponds to an identifier. So you see there's a primary, it's shown in green on the slide, and there are a lot of authorized mirrors. You go to any one of the mirrors or the primary, and it will tell you essentially what you need to know about the next step in the chain. This is the thing that was objected to, because if everybody has to come to us to do all the administration, it meant that many applications just never would happen because they can't trust anybody doing the administration if it was governmental information or even military information, I suppose. So the foundation was created earlier this year to enable multi-party operation of this global registry. We actually built the multi-administration version of it a few years ago, and we were evaluating it ourselves. Now we've got other parties involved in it. We call the administrators multi-primary administrators, or MPAs, and we are now testing the viability of this concept with them on the internet today. What the DANA Foundation will do, it stands for Digital Object Numbering Authority. We'll probably subtitle it as Managing Digital Entities of all kinds, because digital entities and digital objects are essentially the same thing. It will oversee the stable operation of the Global Handle Registry, but it won't be the primary operator any more than an organization that manages air control over, let's say, a country's airspace runs all the airplanes that fly in that space. So the operation will be run by the administrators who will come from around the globe, but the oversight of it will be the foundation. But more importantly, it will be and get involved in the creation or the stimulation of various outreach activities, mainly in the developing world. So we'll probably start out with a healthcare initiative initially. It's going to take use of all of the networking technology that not only people in this room but others are creating. So I'm sure these will be wireless and IPv6 and any combination that you can imagine. But this is all about the information and how you manage the information. It will be a multi-stakeholder organization. It'll have a focus primarily on the technical aspects of the system, and it'll have an ability to reach out into other organizations to get advice on matters that may turn out to be non-technical. In terms of structure and function, it will have a board consisting of up to 25 members. I think initially there'll be 7 plus 1 temporary member to help get it started who's actually legal. An executive director reporting to the board. Most of the activities of the foundation are going to be on outreach because the literal operation of this system is going to be done by others, so they'll have to get to the oversight of the handle system from time to time, but I would guess 95% or more of its activities will be on outreach. But one of the things it will do, question we were asked initially, was if you wanted to add one more administrator to the system, who gets to decide that? Well, originally we said we'd be happy to, and they said that puts us in a special case. So the foundation can and will do that job. It will probably advertise, authorize, and credential new MPAs. What it will do is maintain N+1 of the records in the global registry. The MPAs will create and maintain all the others. The records it'll create is one credential for every MPA that gives it its authority to operate if you wanted to securely check things in the system, which we encourage everybody to do, and all the client software does automatically. And one for the root, which essentially gives you the scope of the system and the whole system-wide credential. So there are multiple keys used for different purposes. The foundation is also the party that's going to sign all of those N+1 records. Now, there's not a lot. It might be 10 or 20 records initially, but you might have hundreds of thousands of them in the system. The rest of them will be signed by the MPAs. So you'll have a built-in chain just like you do in DNSSEC, except it's much more intrinsic in this case. In terms of distributed management, it's going to look like this. Instead of having one primary and a lot of mirrors, now you'll have everybody that's authorized to operate in the system will be essentially parallel. And every MPA will be required to be on a dual stack. Every MPA will be required to mirror the other MPAs. Part of the issue we had here was how do we put appropriate limits on it. And one gave out billions and another one gave out tens. It's kind of an imbalance, but we think we have an approach that's going to lead to fairly uniform mirroring requirements. In order to do the updates, I mean, you can obviously imagine some of the security challenges that are built in here. At one point in time, we talked about building a bakery ticket algorithm. So you pick the next bakery ticket online and assign that as the prefix. But we are going to take a slightly different approach based on the original credentials that you're given. But every MPA will essentially do the checking of the things that are given to it. So that the updating is done on a transaction basis. And so nothing will come into one site that doesn't pass the security checks from the appropriate other site that should have been to this in the first place. And we'll be able to tell. That doesn't mean you can't have a rogue MPA. You might, in which case all the mechanisms that are being checked out in the testbed now are intended to validate whether that is in fact the case or not. When we were running the system, we used to do all kinds of checks behind the scenes. We'd download all the databases, we'd run full tests, we'd do separate tests as well. So we have the same kind of problem here, and it's going to have to be a collaboration. But one of the things that we will require is that all of the MPAs collaborate with all the other MPAs on the policies and procedures to actually make this work. Status and plans, we are still responsible for the global registry. At some point, we will declare the MPA testing over, declare the software fully working, and then we'll turn over the operation of it to the Dana Foundation. I think this is going to happen in the next probably 2 months at most, certainly the first half of this year. This test bed has been in progress for a while. So far, it's working fine. We can't say for sure that we have identified every single possible way that this could be subverted, but we are trying to find every single one of them and check them out in advance so we can understand how that could happen and we can detect them. We will essentially have an agreed limit on these number of records that can be created, and we'll be able to adjust that number up. We're talking about 1 million records per MPA initially. We think that's more than will be needed. Famous last words, remember we thought 256 networks would be sufficient. And we'll see how that plays out over time. But right now, it's hardly any demand on the system at that level. We think we could probably go up by orders of magnitude and still make it work effectively. So just in conclusion, just wanted to say I think there are really very significant advantages for considering the use of the handle system for management and use of IPv6 addresses. I know some of you are already looking at that. This is not intended to replace what IPv6 does in its network context, because that's a kind of a real-time interpretation and movement of data. This is more at a macroscopic level, not only how you might want to manage it in time, but how you may even want to manage it for future purposes as well. You might want to know a particular IPv6 address at one point corresponded to the refrigerator in your home. How are you going to know that in 10 years or 50 years or whatever, and why would you want to? But it would provide a uniform means of identifying all of these IPv6 addresses, and my guess is it is going to be the appropriate choice for both addressing and routing purposes at the lower levels. I think it offers an extreme amount of flexibility because you can decide what resources you want to identify. You can associate the properties that go along with them, totally under your control. And I think it's a very appropriate intermediate level of mapping, especially where people want to put semantic mappings on top of that, because those semantic mappings will want to differ from country to country. You need an intermediate representation that lets you then go back down into the lower levels. So I really gave you a glimpse at this from the point of view of how it might be relevant to IPv6, but I would simply point out it's relevant to so many other things, and in particular, it could be the linchpin for getting interoperability between information systems of all kind, both now and going forward into the future. So thank you very much. If you have questions, I'll be happy to take them.
Just wanted to check on a couple of items that, in the case of IoT or 5G, maybe the cost points, if we compare it to DNS, how much would that cost?
Well, the only charges that we have ever applied have been to offset the cost. So we've been subsidizing it for 20 years. So this is not a money-making proposition, in case you're thinking that that's the case. I think that once we go into this multi-mode, every one of those MPAs will be able to set their own standards. Some may be willing to do all that registration for free. That's okay too. Now they'll have their own models of how to, recover costs. The software is all free.
So your cost model today is how much per country, or?
Depends on how you want to organize it. Let me give you an example. Suppose you took China as an example. China has more than 1 billion people. In principle, if they wanted one administrator in the whole country, they could get one prefix for the whole country, and it would cost, I think we charge $50 a year. So in principle, for $50, they could do it for the whole country. I can't imagine anybody who would want to. We've rarely run across organizations that prefer to do it that way. Normally, take a university. A university might have, a few dozen departments, which they'd want to get separate authority to. So if they got a top-level number, let's say 1,000, they might give 1,000.1, .2, .3, or name. They could introduce alphanumerics at that level. The different departments, or even individuals, they could name their students. They could do all kinds of other things at this prefix level, and those would have to get registered. In our case, we set a clip on it, and we said if you have, in case of the publishers, for example, if we went above a certain level, we'll just cap the charges at that point. But I think people will have different business models of how to deal with that. It just needs to be able to be sustained and supported in terms of its functionality. But this is a tiny part of the...
No, this is the most important part, because if I see the IoT and the 50 billion, a trillion of devices, I guess the current DNS model won't function in one scale anyway.
No, I think... if you look, there are different price levels for different services in the Internet today, and this is going to be at the very lowest level in terms of
The other one
costing.
that you didn't mention is you have a global PKI for this, which is quite unique.
It's not so much that we have it, it's just that it's intrinsic. That is, if you have a mechanism where people can essentially register entities that are individuals, then in fact for the identifier for that individual would resolve to, among other things, the public key for that individual. It comes with the system automatically. So, for example, if you're trying to get to a medical record, the doctor who created the medical record in the first place would probably have attached to that record in something like the repository the identifier of the parties that are allowed to access that record. So the control is at the individual digital object level. But in order to make that work, you then need to be able to understand what the public key is for that identifier so that when somebody makes the request, you can challenge it and say, prove to me you are the person who has the private key that goes with the registered public key for that user. And it's all in turn protected under PKI itself.
Which basically the authentication becomes...
it's intrinsic. It just comes for free.
Which we don't have at all currently in the
Well,
IT world.
there's nothing more you have to do. It's just that other than that, people have to then become registered. And so if I were, a medical doctor, I wouldn't be questioning whether this is the right identifier for the patient because this is the identifier the patient is telling me to use for purposes of release. If you're trying to deal with business transactions over the net, you may want to know more about the party that did the identification in the first place if the party was actually critical as opposed to just a payment. But there's been a tremendous amount of work done on things called trust frameworks and how you go and vet those parties. And in fact, that's one of the things that's mentioned in that X1255 paper as something that's important to know about when you have the personal contact with the individuals to know.
Should we allow a question? Yes. Yeah, just one. Yeah, because John is already waiting, eager to.
I need a mic. Thanks, Bob. There's been, from various visionaries and research, et cetera, when looking back over networking over the past 120 years, that there's, back in the beginning it was hard circuits, then it became virtual circuits, and that we're living in the age of the endpoints, where IP endpoints, and that one day it's all going to be about the content, all about the data, and it's content-centric networking or identity-centric networks, ICNs, CCNs. Do you see this as a potential way to store the signed data chunks in that vision? Or
yeah, you could think of it that way, but let me just tell you that, I have seen so many examples where organizations or individuals thought they were going to supply the solution for the future. It turns out the only solutions that tend to work are where there's local choice, what you can do, where you can have different alternatives, and even where you need to get commonality, it's got to come through some socialization mechanism. I think the most important thing that we did with the internet wasn't so much coming up with the protocols, although that's what everybody sees and that's what we get awarded for, but it's the social structures that were created. We created the ICCB originally, we created the IETF, we created the IAB, we created the Internet Society, and although I wasn't personally involved in creating ICANN, I actually did those functions, for the first 10 years. So these social functions have been probably the most important thing for creating the stability of the internet going forward. And about every 10 years, something changes in some dramatic way. If you recall back in the 1970s, virtually every government, including the U.S., was committed to using the ISO standards, the international standards that were coming out, and it didn't happen. And the reason it didn't happen was it was designed top-down rather than bottom-up, and by the time they were ready to go, there were no structures in place, social structures, to actually support it. So those are extremely important. I'm very sensitive to that, but I think the point that you make is that this is something that could apply, but it was purposely done at a low enough level that these are just building blocks that need to be there in common for people to have a fighting shot at building a long-lived system with security and interoperability that can be understood. But it doesn't come as a turnkey package system, and that's by choice, and that's both good and bad. The bad part about it is it's going to take longer because people then have to relate to the pieces, they have to understand the pieces, they're naturally probably going to try and come up with other alternatives. That's natural. It happened with the TCP IP stuff in the early days. When you kind of took a kind of long, hard look, you realized that it wasn't like alternative A was much better than B, that maybe it was a slight variant in one way, shape, or form. One had thick sockets, the other one had unlimited sockets, one had, there's little variance in one way or another, and I think we need to put that behind us because the bigger issues have to do with what's the information, what are you using it for. I mean, we're going to be flying from here later to Dublin, where there's the third RDA plenary. This is the Research Data Alliance that was set up as a joint effort of the U.S., the European Commission, and Australia. They're going to bring other parties in. Their questions are, if you got a big chunk of research data, how do you know what it is? How do you know how to find it in the universe? How do you describe it? These are big ticket items for which all of the networking stuff that we're doing is absolutely critical, but it's a step on the path to some larger objective. And when we started with networking back in the 70s, nobody, I gave a lecture at the National Academy in the U.S. once a number of years ago, and it was one of those Intel science searches, or maybe it was Westinghouse at the time. A lot of, 1,000 young kids, all at the top of their profession. And this young lady got up to ask me a question on behalf of a 15-year-old lady, very articulate. And she said, on behalf of everybody, we'd like to thank you for, the internet, but what we have is one basic question. We want to know how you managed to convince the governments of the world to let you build the internet. And I said, you're not going to like my answer. I said, a few of us thought it was a good idea, but almost nobody in the world thought this was a good idea back then. So they didn't think it was going anywhere, and they thought it would fall of its own weight. So they said, have at it. And somehow, magically, it somehow caught on, to their surprise. I think we're going to find the big challenges in the future will be about the information and what we do with it. And when I say information, I don't mean just like movies and books and copyright-related stuff. Everything we're talking about managing here is information at some level. The switch settings, even the IPv6 addresses or v10 addresses or whatever. Everything is informational when it's in digital form, and it's the ability to manage that in all its manifestations that's really going to be what this technology is really all about in the future. So the sooner we can get our hands around that, the better, and I think this is my best shot at it. Is it the final shot? No way. I think people are going to look at this and probably say, okay, I think we can build on that, and then they'll learn from that, and then somebody will create something else that's better. Maybe somebody's student or maybe one of the companies in the audience. And that's just the way of civilization. Better ideas lead to even better ideas. And that's what will happen here, I'm sure.
Thank you very much. We'll promote the handle system on your behalf. Thank you very much. And you gave us a very good